Oh, wow, pre-calc. Am I glad to see you? Hey, solve this do now, huh? I'll hang out. Okay, nice work. So before we check out the answers you got for the do now, we probably ought to refresh our memory about what is the zero product property. Because a lot of times people will look at the directions and be like, I don't know what the zero product property is. I can't do this problem. Yeah, you can. All right, so pop quiz. Quick, what's 0 times 0? Nice job. Yeah, that equals 0. How about 0 multiplied by the quantity x minus 1? Nice. Also 0. All right, here's a hard one. 0 times 41,968,637. Yeah, I thought I would catch you on that one. It's such a big number. You could use your fingers and stuff, but 0. And lastly, the quantity 1 plus x times z. Also 0. Man, I can't catch you with anything. All right, nice job. Hey, so let's look at what these problems all have in common, because that's where the zero product property comes into play. So first, we probably caught on to the pattern here that all of them have the answer of 0. Maybe also notice that they are all products. Every single one of those is a multiplication problem. And lastly, each of the original problems involved a 0 as one of the things we're multiplying by. That, by the way, has a special math name. It's called a multiplicand. And that is the only way that we can get 0 for an answer to a multiplication problem. The only way that happens is if at least one of the multiplicands is 0. Of course, these examples only had 2 multiplicands, but there might have been more multiplicands there. At least one of them has to be 0. It's the only way this works. So back to the do now. The zero product property says as long as we get an answer of 0 and we're multiplying a green thing times a blue thing, then either the green thing or the blue thing, perhaps both of them, must be 0. So we take the little expressions out of the green part, set it equal to 0, solve for x. Do the same for the little blue part, take the expression out of the parentheses, set it equal to 0, solve for x. And hopefully those are the solutions that you already got. Nicely done, pre-calc. So today we're going to be looking at solving trig equations. We got some steps. We've been using the truncated version of the steps. We've just been step 4 and 5, solve for the trig ratio, and then use the unit circle to get the angles that would give us the coordinates referred to by that trig ratio. But today we get to uncover the preceding steps, starting with not number 1. Well, actually, we got to start with number 1. Number 1 is super, super important. We're just not going to have to do any work on step number 1 today. But the most important place we have to start is that equation must be equal to 0. If it is not already solved for 0, then we need to get it to equal 0. Move all of the terms to one side of the equation so that it is set equal to 0. Step 2, we're going to factor. If you want to use a different approach to solving, if one is possible, that's certainly fine. Step 3, set each of the factors equal to 0, just like we saw in the do now. That is using the zero product property. And then we pick up with the steps that we had before. Solve each of those factors, little factor equations, solve each one of those for the trig ratio. And then lastly, step 5, use the unit circle to find which points on the unit circle will give you the coordinates specified by that trig ratio once you have solved it. Example number 1. Find all the solutions for the trigonometric equation in the interval, and then highlighted in yellow there in the directions is interval notation we haven't learned yet. So I've translated it. When you're looking for values of theta between 0 and 2 pi. All right, the things that exist on the unit circle, none of that extra business, extra rotations. So here's our equation. 2 sine squared of theta minus sine of theta minus 1. And that is equal to 0. So step 1 in our process is taken care of. Now we get to proceed with factoring. I'm going to suggest that we utilize U substitution at this point for 2 reasons. 1, it's not going to look as confusing, and 2, it's actually going to make writing all those steps here a lot faster. So I'm going to rewrite the problem using a U. 2u squared minus u minus 1 equals 0. Now let's solve. So my first coefficient is a 2, and then we got a -1, and then we got another -1. Just so we don't get weirded out, let's fill in that missing 1 right there. Okay, next I'm going to multiply the yellow leading coefficient and the blue constant. So 2 times -1, that is -2. List every single possible pair of factors that would multiply to get -2. And there's a ton of them. By ton, I mean hardly any at all. So now I need to go back through this list and find out which pair of factors would add together to make that green coefficient in the middle term. So the -1. Would these add to make -1, or would these? These or these? Right, okay, you already knew that. +1 and -2. So let's rewrite this equation. 2u squared. I'm going to do all the black ink first. -1 equals 0. Come back with the green. So I'm going to break that middle green term apart into two terms, the +1u and the -2u, which I identified from my list of factors over there. Now I've got 4 terms, and the 4 terms will fit just perfectly inside my 4-spaced factor box. So 2u squared plus 1u minus 2u minus 1. And let's go across first. Mystery number, that top row, greatest common factor. That's a u. The red u multiplied by what would give us 2u squared? Well, we'd have to multiply by 2u. Move the mystery circle. That red u multiplied by what would give us the next term of 1u? That'd have to be multiplied by +1. Oh, changing colors. Crazy. All right. Bring that over here so I can still see it. Bring that down here. Okay, last mystery number, the blue 2u multiplied by this next mystery number will need to give us the term in the bottom left-hand square of my factor box. 2u multiplied by what? It's going to give us -2u. Well, that would have to be multiplied by -1. All right, lastly, let's just double check. Do the two numbers in the circles give me the last term in that factor box? +1 multiplied by -1. Yes! Okay, let's write down the factors. 2u plus 1 from the blue ones is one factor. And in red, I got u minus 1. Okay, we need to remember this equals 0. Okay, we haven't done anything with the 0 yet, but it has to be there. Otherwise, we can't actually do anything else. So as long as this is equal to 0, we're good. The steps, if you check back in your notebook, the next step is to solve each of those two factors by setting it equal to 0, and then solve for the trig function. Well, the catch here is that I could totally set them equal to 0, but there is no trig function. So here's what's going to happen. I'm going to combine some steps just to save a little bit of writing. I'm going to take that blue factor, set it equal to 0, but I'm also going to substitute that u back into sine of theta. So 2 sine of theta plus 1 equals 0. And then I will do the same thing for the red factor. So I'm going to change that u back to sine of theta minus 1, and that is equal to 0. Now, solve each of those separately. Subtract 1. So 2 sine of theta equals -1. Divide by 2. I don't have enough room. So sine of theta equals -1/2. Okay, let's go back to the red equation, solve that one as well. It's going to add 1 to both sides, and then it's going to bring me sine of theta equals 1. Go ahead and bring that down a little bit so these line up. Okay, last step in this process is go to the unit circle and find which angles measured in radians give me that specified coordinate. What coordinate? Well, sine of theta refers to the y coordinate on the unit circle. So I'm looking for points on the unit circle that have a y coordinate of negative 1/2. We'll write those into this blue answer box. Now we'll be doing the same thing with the red. I probably can't remember that many things at a time, but also sine of theta. So I'll be looking for where the y coordinate equals positive 1. Well, let's do the blue one first. So y coordinate negative 1/2. Okay, the y coordinate of negative 1/2. Here's 1 and there's 1. So that'll be 11 pi over 6, 7 pi over 6. The other one from the red equation said that sine of theta equals 1. And so the y coordinate of 1 happens right up here. So that is pi over 2. So let's see if I can remember all of that and write them down. So I got 7 pi over 6 and 11 pi over 6 for the blue one, pi over 2 for the red one. Mm-hmm. 7 pi over 6, 11 pi over 6, commas. And, pi over 2, we'll make it red. All right. So, end of example number 1. Example number 2. All right, first thing we're going to check out here is we're going to make sure that this equation is set equal to 0. It is. That's great. Next, I'm again going to utilize u substitution. This time, u will be cosine of theta, since cosine is in this equation. 2 cosine squared of theta minus 3 cosine theta plus 1 equals 0. So when I make that substitution, 2u squared minus 3u plus 1 equals 0. And now we're going to factor step 2 in the process. So let's identify the coefficients. Multiply the yellow coefficient times the blue constant. 2 times 1 is 2. Now we make a list of all the possible factor pairs that will multiply to give us negative 2. And then we're going to go back through this list and add, this time looking for which of those factor pairs is going to add to give us that green coefficient of negative 3. Is it 1 and 2? Or negative 1 and it's negative 1 and negative 2. All right, so we're going to split apart that center term in the original equation. Negative 1u minus 2u and plus 1 equals 0. Now I've got 4 terms. I can drop those 4 terms into my factor box. So 2u squared minus 1u minus 2u plus 1. Let's take a look at this top row first. What is the greatest common factor of 2u squared and negative 1u? Well, that's going to be a u. Mystery number here. That red u multiplied by what? It's going to give us 2u squared. It'll be 2u. Red u multiplied by what? It's going to give us negative 1u. It'll be negative 1. Move that here, move that there. Blue 2u multiplied by what is negative 2u? It's going to be negative 1. And then lastly, double check these two circled numbers that actually multiply to give us that last bottom right-hand term. Yes, they do. All right, so we got 2u minus 1. That's our blue factor. We got u minus 1. That is our red factor. Equals 0. We can't forget the equals 0. And then that brings us to step 3. We're going to separate each of those two factors, set each factor separately equal to 0. Set it equal to 0. And while I am doing that, I'm also going to go ahead and substitute that u back as cosine of theta. Because otherwise, I won't be able to do step 4. Cosine of theta minus 1 equals 0. The red one, u minus 1 equals 0. Not you. Cosine of theta minus 1. Okay, so step 4 is to solve for the trig function. So if I had left the u there, I wouldn't be able to solve for the trig function. So I just wanted to combine those two steps. It saved me a little bit of writing. My next step is to solve for cosine of theta. Let's do the blue one. So I'm going to add 1, and that brings me to cosine theta equals 1. Divide by 2, divide by 2. Cosine theta equals 1/2. Now let's look at the red one. Add 1 to both sides. Cosine of theta equals 1. All right, step 5. Last step. We're going to go to the unit circle, find what values of theta would give me that coordinate. Wait a minute. That coordinate. What coordinate? What coordinate? Ah, yes, what coordinate indeed. Well, cosine of theta, that's the trig function that shows up in both the red and the blue parts, and cosine of theta refers to the x coordinate. So we're going to look on the unit circle for points that will give us an x coordinate of positive 1/2, that's for the blue one, and positive 1 for the red one. So positive 1/2, two places where that happens, pi over 3 and 5 pi over 3. And positive 1, that happens just the one spot there circled in red. So that point, we do have two options. We could call it 0 radians or 2 pi radians. That's the way they're labeled on the unit circle. However, the directions on my problem specified that I was to go from values of theta at 0 and including 0 up to 2 pi, but not including 2 pi. So I've gone ahead and scribbled off the 2 pi. I'm not going to use 2 pi as a possibility here. So 0. Okay, so let's take those answers back and write them down. So I got 0 radians for the red one, pi over 3, and 5 pi over 3 for the blue one. Pi over 3, 5 pi over 3, and the red one was 0. The red one was 0. Yeah. So there you have it.